Hello and welcome. In this video, we would like to give you a first introduction to line scan cameras and explain why you should consider using line scan cameras in your machine vision applications. We will point out the major differences to area scan cameras, show the advantages and inherent challenges of line scan cameras, and show their most common use cases. To better grasp the concept of line scan cameras, we will first compare them to area scan cameras, as area scan cameras are more commonly used in machine vision applications. The difference between the two types of cameras lies within their sensors. While an area scan sensor is capturing a two-dimensional array of pixels, the line scan sensor is capturing single lines of pixels, one at a time. These lines then need to get stitched together to form a two-dimensional image. Area scan cameras are generally more cost-efficient and easier to set up and use, but line scan cameras hold several advantages over area scan cameras. First, due to the number of lines used to create one two-dimensional image only being limited by the processing device used, line scan cameras allow for images with theoretically endlessly high image size and clarity in one direction. This results in images with very high resolution, even compared to the highest resolution area scan cameras. For example, if you are capturing 32,000 lines using a 16,000 pixels line scan sensor, the resulting image will have a resolution of 512 megapixels. Since there is only one line of light-sensitive pixels, the sensor can be read out in rapid succession. To produce good images using the fast readout rate, lighting must be optimal so that the exposure times can be kept short. To achieve this, the lighting must be very bright and have a high frequency. For line scan applications, however, only a small strip of the object must be illuminated. Note, there are also line scan sensors with multiple lines of light-sensitive pixels. These allow even shorter exposure times due to the higher number of light-sensitive pixels. When all these requirements are met, line scan cameras allow for high-speed inspection applications. Example applications for line scan cameras would be continuous web inspections, applications where objects are moved by a conveyor belt, and applications where the camera is moved by a sled. Additionally, line scan cameras allow the inspection of the jacket of round objects without cylindric distortion, much like it is shown in this animation. One challenge inherent to line scan cameras is that to get a two-dimensional image of an object, either the camera or the object to be captured must be moved. Going back to the already shown conveyor belt application, the camera here is stationary, and the objects are moving. To achieve an ideal 2D image and to avoid distortions, the resolution, pixels per millimeter, should be identical in both X and Y direction. This directly translates to the movement of the conveyor belt needing to be perfectly uniform and constant. This is, however, impossible within a real-life scenario. If the movement speed of the object is too fast for the line acquisition, the acquired images will be compressed. If the movement speed of the object is too slow for the line acquisition, the acquired images will be stretched, or worse, won't be fully captured, like in the animation shown. In real-life application, the movement speed of the object won't even be constant and will vary. Therefore, to prevent distortions within the 2D images, an encoder is used to synchronize the varying movement speed of the object and the line acquisition rate. There are two types of encoders, rotary and linear encoders. Here you can see a rotary encoder. Encoders generate synchronization pulses based on the movement of either the object, which can be moved by, for example, this conveyor belt, or the camera that could be moved by a sled, for example. Some encoders can even tell in which direction the object is moving. This can be helpful in several applications. One example is the application shown in our second video about line scan cameras. This concludes this video. We hope this introduction to line scan cameras was helpful to you. If you want a more in-depth look into line scan cameras and how to operate them together with MVTech Halcon, please watch the video How to Set Up and Use Line Scan Cameras with MVTech Halcon. Thank you for watching.